All right, boys and girls, today we are going to look at graphing a cosine function. And I just want to give you a heads up that I am sitting outside, so you may hear birds singing. You may hear my swing squeak like that, but I'm just sitting outside enjoying the beautiful day as I make this video. Alrighty, so today we're graphing cosine functions, and we're going to do what we did yesterday. We're going to use the unit circle to complete our table. So remember, here's our handy dandy unit circle. And so we have to find our value. So when we go cosine of 0, remember cosine is an x value. So the cosine of 0 is 1. And then we want to look at the cosine of pi over 2. Once again, cosine is an x value, so we see that that's 0. Then we want to look at the cosine of pi. Coming down again, pi is an x value, so that's going to be negative 1. And the cosine of 3 pi over 2. Now you should start to see a pattern from yesterday. So the cosine of 3 pi over 2 is going to be 0. And then the cosine of 2 pi, we're back at 0, so that's going to be 1. So when I graph this, cosine looks slightly different than sine. So I'm going to do what I did yesterday. This is going to be 1 and this is going to be 2. So at 0, cosine is 1. At pi over 2, cosine is 0. At pi, cosine is negative 1. At 3 pi over 2, cosine is 0. And at 2 pi, cosine is 1 again. So it sort of looks like it's unfinished almost. So it looks like that little cup. But if we continue this pattern on the other side, we see that it does make a full circle. So on the other side of it, it looks like this. And if you put those values in, you'd get the same thing. Because just like sine, it's repetitive. Okay? So looking at cosine, how does cosine differ than sine? Well, what's the domain of cosine? Well, just like sine, I can put any number into this function and get a value out. So my domain is negative infinity to infinity. The maximum value, once again, our maximum value is 1. And our minimum value is negative 1. So just like cosine, my range is negative 1, 1. And the period of a cosine is also 2 pi. Okay, so cosine function is very similar. And as a matter of fact, a cosine function is just the sine function shifted to the left. Because if you notice, if the sine function had started here, we went up, we came down, we went back up, that's the sine function. So it's just a sine function shifted. So because of that, I'm not going to take a lot of time with this. I just want to show you a couple of things. So negative sine is going to look similar, except for instead of starting at 1, it's going to start at negative 1. And then 0, and then 1, 0, negative 1. Because all I'm doing is just taking these values and multiplying. I'm taking these values and multiplying them by negative 1. Because that's just negative cosine. So negative cosine would start at negative 1. It would go to 0. It would go to 1, back to 0, and back to negative 1. It sort of looks like an upside down parabola. But unlike a parabola, it keeps going on and on and on. So it would start to go back up. And that is so wrong. Sorry. So here we go back up to pi over 2. And then it would go up to 1. Then back down to 0. And then down to negative 1. So that's what negative cosine of 1 would look like. And the reason this looks so jacked up is because I went up too far. This should come down here. I was wondering why that looked like that. But never mind, that's what it looks like. And once again, our domain would still be all real numbers. And our range would still go from negative 1 to 1. Okay? So let's look at doing a vertical stretch. So what I'm going to do, just to kind of show you this, I'm just going to graph the normal cosine. So I'm graphing cosine of theta, what we just graphed. So cosine theta looks like this. So what would 2 cosine theta look like? It would just be a vertical stretch. It's going to look similar, except for it's going to go to 2, 0, negative 2, back up to 0, and then up to 2. So 2 cosine theta will sort of look like that. and it would continue on, because all we've done are we've taken these numbers from cosine theta and multiplied it by 2. So it is a vertical stretch. So these numbers would be 2, 0, negative 2, 0, 2. And again, the domain, negative infinity to infinity, range, negative 2 to 2. Half of cosine theta, I'm going to graph cosine theta again, because that's pretty much what it is. It's just the transformation of it. What did I do wrong? That needs to go to 0, and then that needs to be at 1. So cosine theta looks like that, and then half of cosine theta would be half of that graph. Let's get another color, let's say purple, and instead of starting at 1, we would start at a half. We'd go to 0, then to a half, back to 0, and then to a half. So that would look like that. Okay? Because all we did was take the numbers from cosine, multiply by a half. And you can graph this on your calculator to see what it looks like. So this is be a vertical shrink. And this applies to the cosine function as well. So my values would be 1/2, 0, negative 1/2, 0, 1/2. Cosine 2 theta. Now remember, this is where we have our period changes. And instead of taking it 2 pi to complete a cycle, it's going to take it half that time. So it's going to complete a cycle at pi, which is why we changed our numbers. So we see that these numbers are going to be the exact same, except for our theta has changed. So cosine of 0 is still 1. So that's cosine of 2 times 0. This is cosine of 2 times pi over 4, which is cosine of pi over 2, which is 0. This is cosine of 2 times pi over 2, which is the same as saying the cosine of pi, which is negative 1. The cosine of 3 pi over 4 times 2 is the cosine of 3/2 pi, which is 0. And then, of course, when we go back to pi, that's the cosine of 2 pi, which is 1. So that looks like it's all doing it, but notice that my theta has changed, so it's going to do a full cycle in 1 pi's time. So this period changed. And if we continue the pattern, we'd see that it continued to look like that. And it would come and go like that. There you go. I keep 1, 2. Should go down like that and come back up. Okay? But it completed its cycle from beginning to end in 1 pi. But my domain is the same and the range is the same. Okay? All right, so that is it for graphing cosine. It looks very similar to sine. Come back to the next video and we're going to look at some more features of the cosine